Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is solving quadratics by completing the square day 1. Part 1, we're going to look back at perfect square trinomials and how to factor those. So we need to go ahead and factor the following perfect square trinomials. The first thing we want to check is are there any GCFs? There are not. Then we're going to look and see, is my first term, my x squared, a perfect square? Yes, it is. Is my last term, the 25, a perfect square? Yes, it is. So then I'm going to use both positive because my last sign is positive and my first sign is positive. So both my signs in the back, or both my signs in my parentheses will also be positive. And so I would take the square root of 25 and put it in the back. The square root of x squared, put it in the front. That would leave me with x plus 5 squared. Then on to number 2. Again, I would look for a GCF. There is no GCF, so I can make my two sets of parentheses. The sign in the back is positive. The sign in the front is positive. Is x squared a perfect square? Yes, it is. So I can put the x's in. Is 64 a perfect square? Yes, it is. So the 8's can go there. Now I can write it as x plus 8 squared. Last one, number 3, is x squared a perfect square? Yes, it is. Is 36 a perfect square? Yes, it is. So I can put my x's in. Since my back sign is positive, my front sign is negative, these will both be negative. 6 and 6 from the square root of 36. And I have x minus 6 squared. That is actually review. Okay? On to part 2, solving perfect square trinomial equations. We need to solve the following equations for the given variable. What I need to do here is I need to go ahead and factor what is on the left-hand side. I'm going to factor this, okay? So here again, I'm going to look, is my a squared a perfect square? It is. Is my 49 a perfect square? It is. My sign in the back is positive, my sign in the front is negative, so they'll both be negative. The front blank gets a, the back blank gets 5 from the square root of 25. I can rewrite a minus 5 times a minus 5 is a minus 5 squared. All that is still equal to 25. So I really have done nothing different there. I just had the equal 25 next to it. From here, what I'm going to do is take the square root of both sides. That would give me a minus 5 is equal to, what is the square root of 25? It is plus or minus 5. Hopefully you're starting to catch that. Now, what I need to do here is, because this plus and minus 5 is actually two numbers, it's positive 5 and negative 5, what I'm going to do is I'm going to take a minus 5 and set it equal to positive 5, and I'm going to take a minus 5 and set it equal to negative 5. I go ahead and add 5, so a could be 10, or add 5, a can be 0. So really there's only one extra step there, or two really. After I square root it, then I'll have the a minus 5 just on the side by itself, plus or minus the square root of the number that the entire equation was set, or the other side of the equation, the 25 in this case. So the square root of 25 was plus or minus 5. Then I break it into two separate equations. All right. On to 5. Again, b squared is a perfect square. 81 is a perfect square. So I can set this as b plus 9 times b plus 9 is all equal to 4. That can be b plus 9 squared is equal to 4. Square root, so b plus 9 is equal to, what is the square root of 4? Your calculator is going to just say 2, but we know better. We know it is plus or minus 2. So then I can break it into two separate equations. B plus 9 is equal to 2. B plus 9 is equal to negative 2. I need to subtract 9 from both sides. So b would be equal to negative 7. Subtract 9 from both sides. B would be equal to negative 11. Okay? All right, on to part 3. We're creating perfect square trinomials. So we need to find the term that should be added to the following expressions, and then we're going to factor the expression. How we're going to do that is we're going to take our b value. So this would be, it would be b over 2 squared will give us our c value. You don't need to write that down. Probably should have told you that beforehand. I apologize. But that is our formula that we're going to use. So my b value in this case is 2. So it would be 2 over 2 squared. which is equal to 1 squared, which is equal to 1. So my C value is in fact 1, and that comes from right here. That will go there. But I can use this one to actually write what my factored form would be. So it would be x plus 1 squared, which is x plus 1 times x plus 1. Really just going backwards there. I'm going to go ahead and how I want to actually write this when I do these problems later is going to be this x plus 1 squared. That's the farthest I really want to go. All right. So on to number 7. I have this negative 4, so it would be negative 4 over 2 squared. If my b over 2 turns out to be negative like it is here, negative 4 divided by 2 would be negative 2. I want to put that in parentheses, so when I type that into my calculator, it'll come out correct to positive 4. All right. So my C value is positive 4. Now I can take my negative 2, plug it into the equation as x minus 2 squared. Okay. On to number 8. Again, I'm going to use my b value. So it'd be 6 over 2, parentheses squared. 6 over 2 is 3 squared. In fact, you know what? I'm just going to start putting all of these in parentheses. That way, it's the same process every single time. So 3 squared would be 9. You can put 9 there. The 3 can come out and make it x plus 3 squared. That is my factored form. All right, on to the back. Now I'm going to use the same process to solve the following equations by completing the square. What I have to do here is our blanks are the same thing that we did in part 3 on the front there, where I take my b value divided by 2. So I need to take my b value, which is 10. So it would be 10 divided by 2 squared, which is equal to 5 squared, which is 25. I'm going to put that 25 in both blanks. Okay? From here, I can take my 5 from here and make it into my factored form, which would be x plus 5 squared would be equal to, what's 24 plus 25? That would be 49. Now I can go ahead and square root, which would give me x plus 5 is equal to plus or minus 7. So x plus 5 is equal to positive 7. X plus 5 is equal to negative 7. Subtract 5, x is equal to 2. Subtract 5, x is equal to negative 12. All right? Let's try the next one. So I need to take my b value, which is positive 4. So it would be 4 over 2 squared, which is 2 squared, which will get me 4. That 4 will go ahead and go in my two blanks. I can use the 2 in x plus 2 squared would equal, what's 12 plus 4? That would be positive 16. You can go ahead and take the square root, So it would be x plus 2 is equal to plus or minus 4. Do not forget the plus or minus 4. I need two answers here because my power is raised to the second. So that tells me I need two answers. So it would be x plus 2 is equal to 4. X plus 2 is equal to negative 4. Subtract 2, x equals 2. Solving equations, guys, that is literally review. We've been doing that for a long time, so you should be able to tell me that x plus 2 is equal to negative 4 would equal x equals negative 6. Now, number 11. In this case, my b value is not over with my x squared. I need to get it over with my x squared, and then I will create my own blanks. So I'll subtract 8x. That would get me x squared minus 8x plus blank will equal 48 plus blank. Okay? So now I need to go ahead and use my b value, which is negative 8. So it would be negative 8 over 2 squared is equal to negative 4 squared, which is equal to 16. I can take the 16, plug it into my blanks. I can use the negative 4 to write my expression for the factored form. What's 48 plus 16? Well, that will be 64. Square root, x minus 4 is equal to plus or minus 8. From here, what do I have to do? It's the same process every single time, guys. X minus 4 would equal 8. x minus 4 would equal negative 8. Add 4, so x equals 12. Add 4, so x equals negative 4. All right? Moving on to number 12. Again, my b value is not over with my x squared, so I need to go ahead and bring it over to my x squared. So it would be x squared minus 12x is equal to negative 61. What is missing from here, though? Now I have to make my blanks. So I will add a blank behind negative 12x, and I will add a blank behind negative 61. I can use my negative 12 as my b value, so it would be negative 12 over 2 would be equal to negative 6 squared, which is 36. So 36 can go in my blanks, and I can use negative 6 for my factored form. What is negative 61 plus 36? Well, that will get me negative 25. From here, I can take the square root. X minus 6 would equal. Now, if I have a negative under the square root, I can rewrite that negative as the square root of 25 times the square root of negative 1, which we've talked about before. The square root of 25 would be plus or minus 5. The square root of negative 1 is I. So I have plus or minus 5i. Now, I'm still going to do the same process. I'm going to split up my two equations. Okay? I'm going to add 6 to both sides. This would get me 6 plus 5i. We learned that during the complex numbers lesson, is where we learned about not adding those together because they are not like terms. So we are using prior knowledge to finish these problems. Okay? On to 13. On number 13, I need to get a blank in this location. How can I get a blank there? I can subtract 21. That would get me x squared plus 10x plus blank is equal to, what's 5 minus 21? Well, it's negative 16 plus blank. From here, I can use my positive 10 to write 10 over 2 squared is equal to 5 squared, which is 25. If I put 25 in my blanks, I would end up with, remember I can use the 5 for my factored form, x plus 5 squared is equal to negative 16 plus 25 would get me a positive 9. Square root both sides. X plus 5 is equal to plus or minus 3. Be x plus 5 is equal to 3. X plus 5, whoops, got ahead of myself there. X plus 5 is equal to negative 3. Subtract 5, x would equal negative 2. Subtract 5, and x would equal negative 8. Okay? On to 14. Again, I need to add this 3 so I can create my blank. X squared plus 2x plus blank would equal 2 plus 3 is 5. I can use this 2 to write 2 over 2 squared is equal to 1 squared, which is just equal to 1. Now I can put 1 in for my blanks, right? And I can use this one to write my factored form. Take the square root, It'd be x plus 1 is equal to the square root of 6. We know from our square roots lesson, the first lesson in this unit, that I cannot take the square root of 6. So I'm just going to leave it as the square root of 6, but this is plus or minus. Okay? So I need two answers. So I'm going to split my equation to the square root of 6, and x plus 1 is equal to the negative square root of 6. I'd subtract 1 from both sides, so x would equal negative 1 plus the square root of 6, and x would equal negative 1 minus the square root of 6. And I am done there. Looking at the bottom, it says, think about graphing. If I have x equals something, that is my x-intercepts, right? All of these problems then have changed from standard form to intercept form. We have changed them all from standard form to intercept form. Guys, the biggest thing about this lesson is to understand the process. Okay, I want to get my standard form on a side by itself. Then I want to add a blank. I will use b over 2 squared in order to fill in my blanks. Then I can go ahead and work through the process of solving for x. If you have any questions over this lesson, please, please, please bring them to me tomorrow. Thank you very much for watching this video, and have a great day.